Okay, let's see how you made out solving your assigned problem here. We have two functions, f of x equals 3, g of x equals x squared minus 1. And I actually did the first step for you. I meant to say find f minus g of x, and that of course equals f of x minus g of x, which is where I started you off. So we substitute. 3 is the same as f of x. X squared minus 1 is the same as g of x. I subtract and simplify, and I get minus x squared plus 4. And hopefully that's what you got too. Now, our next topic in this section is the really important one. It turns out a lot of mathematics can be figured out using this concept. Composition of functions. Suppose we had this scenario. We have two functions, f and g. They each take in a real number. They each give out a real number. Suppose we have some number x and we feed it into g. It produces g of x, some other number. Then that number, g of x, is fed into function f. That produces some other number. Well, the number that it produces is f of the number g of x. So in other words, the function g of x here on the inside happens first on the number x, and then whatever that spews out, f operates on that and produces yet another number. This is a very common scenario. It's called composition of functions. These two functions are being composed. F is being composed on top of g in this case. We have special notation for it. F and then this little circle and then g of x. This means f composed on g of x. Looks like it spells fog, but that's not an O, it's just a little circle. Just a symbol indicating an operation. Let's look at example 6. Here they give us three functions. F of x equals 2x minus 5, g of x equals 6 minus x squared, h of x equals 1 over x. In part A, we're asked to find the composition of h on g. On f. In other words, h composed on f of x. Our definition here tells us this means the same as h of f of x. F of x, meanwhile, we know that that is just another name for 2x minus 5, so let's replace f of x by 2x minus 5, as I've indicated in the green here. How does h operate on an expression like this? Well, h is the function that takes whatever you give it. If you call it x, the number you're giving it, it just puts 1 over it. So whatever you give it, it just puts 1 over it, makes that fraction. Here, we're giving it 2x minus 5. So h turns out 1 over 2x minus 5. We're also asked in this example to find the domain in each case. Notice that we have a variable in the denominator, and sure enough, there is a value of x that would make this denominator 0, so we have to outlaw that value, and that value is 5/2. If we plugged 5/2 in here, we'd get 0 in the denominator. So we say the domain is the set of all x such that x is not equal to 5/2. Let's look at the other parts of this example. In part B, maybe I'll put it right up here. In part B, we are asked to find f composed on g of x. As we know from our definition, this just means f of g of x. But g of x equals 6 minus x squared. So we can write that in there if we like. Now what happens? Well, what does f do to any number you give it? It multiplies it by 2, and then it subtracts 5 from that result. So here we're giving it the number 6 minus x squared, whatever that happens to be for various values of x. So we're going to get 2 times the number being fed in minus 5. The number being fed in is 6 minus x squared. Simplify. Oops. Make it like this. 2 times 6 gives me 12 minus 2x squared minus 5. So I get 7 minus 2x squared. What's our domain? All reals, right? You can put any number in there for x and you can square it, so there's no restriction. And part C. In part C, we're asked to find g of f of x. Okay. That means g of f of x. But f of x is just another name for 2x minus 5. What does g do? G takes a number, squares it, and then subtracts it from 6. Here we're giving it the number 2x minus 5. You see the calculations done in your textbook there. I'll just jump straight to the answer. This turns out to be the same as minus 4x squared plus 20x minus 19. Alright, well, it might look like a bunch of hocus pocus to a bunch of freshman algebra students. What does this mean? Well, let's look at part C here for an example of what it means. What we're claiming here, in effect, is that if you fed a number x into function f, and then that value you got out of f, you fed it into g, you'd get a certain number. And what our calculation tells us is that we could feed that same original number x into here and get the same number. Let's see if that actually works. Let's just try x equals 3. If I take f of 3, I'm going to get 2 times 3 minus 5, which equals 6 minus 5, which equals 1. Okay, let's go from there and feed that 1 into g. Right, because that's the situation we're talking about. We take a number, feed it into f, and whatever comes out we feed it into g. What is g of 1? It's 6 minus 1 squared, which equals 6 minus 1, which equals 5. What we're claiming is that if you take that same number, same x value, 3, and you put it in here, you're going to arrive there. We're claiming that you always arrive at the same ending point. Let's try it. Let's go ahead and compute G composed on F of 3. We claim that that function is what that really is. So I replace x with 3. When I get there, I'm going to get negative 36 plus 41, which equals 5. So it checks. This truly is the combination of F and G, with F happening first, G happening second. So always keep in mind, when you do composition, the function closest to your input variable happens first, it gets applied first, then you apply the further away function to the result, to the output of that first function. So, you do a couple of these. On page 270, go ahead and do 12 and 16. All right, let's see what you got. Need my eraser. Works out like this. We have two functions, f of x, g of x. One of them takes x, multiplies it by 3 and subtracts 2. The other one takes x, just multiplies it by 2 and then subtracts the 2. F of g of x, f composed on g of x, equals this. Right here I'm replacing g of x with 2x minus 2. That feeds into f, so it's 3 times that number underlined in the green, minus 2, which gives me 6x minus 8. Is it going to be different if I go the other way, g composed on f? Let's see. F is equal to 3x minus 2, so it's g of 3x minus 2. Feed that into g, so it's 2 times 3x minus 2 equals 6x minus 6. So you see they are different. They usually are. Then we go to 16. We have the functions f of x equals square root of the quantity 3 minus x, g of x equals x minus 5. Part A, compute f composed on g of x. That gives us f of x minus 5 equals square root of the quantity 3 minus quantity x minus 5 equals square root of the quantity 8 minus x. How about the other direction? G composed on f. That equals g of the square root of the quantity 3 minus x. G just takes whatever you give it, subtracts 5, so we're giving it square root of 3 minus x, subtract the 5, and there's our result. Is there any way you can check these answers? Yes. Pick some random x value, such as 2. 2 is good because when I take f of 2, I get square root of 3 minus 2, which gives me 1. Now if I feed that 1 into g, g of 1 equals negative 4. So this is claiming that g composed on f of 2 should equal negative 4. So let's check it out. G composed on f of 2 equals square root of 3 minus 2 minus 5 equals square root of 1 minus 5 equals negative 4. So it checks. So at that point I'm convinced that we probably have the right answer there. for homework. On page 270. Those are done. Well, first, before you get to page 270, go into My Math Lab and you'll see a video for section 4.2. Watch that video, it explains that example I mentioned earlier, that modeling example. Then do numbers 3 through 9 odd, and then do 13 through 21 odd. Okay, see you next time.